Hello everyone. This is NagaLakshmi Devi, Assistant Professor, Department of Freshman Engineering, IARE, Hyderabad, Telangana. Now the Cauchy-Riemann equation for the theorem, the necessary and sufficient condition for the derivative of the function u equal to u of x comma y plus I into v of x comma y equal to f of z to exist for all values of z in a region R. The first condition is we have to solve dou u by dou x, comma dou u by dou y, comma dou v by dou y, and dou v by dou x are continuous functions of x and y in R. These are the analytic conditions. Now the second condition is analytic condition, that is dou u by dou x equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x. Now the problem. Here this is equation, the second equation is called a Cauchy-Riemann equation. It is briefly we call it as CI equations. Now the first problem. Find all the values of k such that f of z equal to e power x into cos ky plus I into sin ky in analytic. Is analytic or not? If f of z equal to e power x cos ky plus I into e power x into sin ky is the given function. Now this is equation number 1. Now here u equal to e power x into cos ky and v equal to e power x into sin ky. Now solving the each and every term individually, that is dou u by dou x and dou u by dou y. Dou u by dou x with respect to x means here cos ky treated as a constant and e power x derivative is e power x. Now similarly dou u by dou y means here e power x is treated as a constant, cos ky derivative of cos is minus sin ky into k. Similarly dou v by dou x that equal to e power sin ky is a constant, e power x derivative is e power x. Next dou v by dou y, similarly that is e power x is treated as a constant, sin ky that is cos ky into derivative of sin ky is cos ky into k. Now therefore dou u by dou x is equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x. Here these two are same. E power x into k, this one. Next here e power x into k. Here which one is irregular here? K. If k is 1, is these both are same? Is it analytic? Therefore we consider k equal to 1. If k is equal to 1, it is k equal to 1, that is e power x into sin y, and here also sin y into e power x. Now here also same. K equal to 1 means cos y e power x into e power x cos y into k value 1. Both are same. Then the k value, find the k value means here k value is 1, then it is analytic. If k value is not equal to 1, that is not analytic. Next one. These are the conditions. Next, limit of a function f of x comma y at a point 0, 0. Now the procedure of the find the limit of x comma y treated as a 0, 0, that is f of x comma y. Then here individually we will call it as L1, y tends to 0 and x tends to 0. This value or something, anyone. Next similarly L2, that limit is x tends to 0 and the limit of y tends to 0 is f of x comma y. That means here limit x tends to 0, y tends to 0. Now here limit y tends to 0, x tends to 0. Now these both are same or not, we can check it, that one. Next L3 is the limit x tends to 0 and limit y tends to mx of x comma y. That is limit y tends to mx, then x tends to 0. And here also same, limit x tends to 0 and x tends to 0. This is y mx square, this is x tends to 0. X tends to y equal to mx extends to 0. And this is fifth one, that is limit extends to 0 and the limit y tends to mx square. These conditions are satisfied, then L satisfied, the limit existable. All the equations are same, all the limits are existable, then limit existable. If it is not equal, any one condition is not existable, that limit is not existable. Limit of two variables. Here also same. L1, L2, L3, L4. Here x tends to 0, y tends to 0 is always L1, and y tends to 0 and x tends to 0 L2. Same, x tends to 0 and y tends to mx and x tends to 0 is L3. X tends to y tends to mx square, x tends to 0 L4, and same. Here also same. This is two variables also same. Next, continuity also we are using that one. Here the continuity definition is function f of x comma y is said to be continuous at a point 0 comma 0 if the following conditions are satisfied. The first condition is f of 0 comma 0 must be well defined. Compulsory, it must be well defined. Then next one is limit extends x comma y tends to 0 comma 0, that is nothing but x tends to 0 and y tends to 0, that x comma y must be existable. And third condition also same, the limit x comma y tends to 0 comma 0, that f of x comma y equal to 0. Why? Because it is well defined. That's why this condition is also satisfied. Then it is continuous function. Then the limiting conditions are similarly in area procedure L1, L2, L3, L4. All are equal, then it is continuous. Otherwise, it is not continuous. Now, here the note is there. If one of the above three condition is not satisfied, then the f of x comma y is not continuous at a point 0 comma 0. All the conditions 1, 2, 3, 4, all the conditions are satisfied, then it is continuous. Otherwise, any one condition is not satisfied, then it is not continuous at a point 0 comma 0. At a point 0 comma 0. Next one, continuity of a complex function. Function f of z is said to be continuous at a point z equal to 0 if the following conditions are satisfied. This is complex function of continuity. The first one is f of 0 must be well defined. Similarly, area type, limit z tends to 0. In area is f of x comma y tends to 0 comma 0 is existable. Now here z tends to 0, that f of z must be existable. And third condition is limit z tends to 0 of f of z equal to 0, then the continuity of the complex function is satisfied. If any one condition is not satisfied, then that continuity is not existable at a point z equal to 0. For example, we can choose this problem. Prove that the function f of z defined by f of z equal to x cube of 1 plus I minus y cube of 1 minus I by x square plus y square if the z not equal to 0 condition. If z equal to 0, the total function is 0. Is continuous and the CR equations are satisfied at the origin. At y dash of 0 does not existable. We can show these three conditions, continuous and satisfied at origin or not, and f dash of 0 does not existable or not. We can see these three conditions. Now, given that f of z is that one, now the limit first, the L1 is limit x tends to 0, y tends to 0. Now substituting first of all, y tends to 0. Now here I am substituting y tends to 0 means y 0, and here y tends to 0 means y 0. Then remaining is x cube of 1 plus I by x square only. Then after here x tends to 0 is also there. Now substituting x cube here, the x value is 0 and here x is also 0. Then we get 0. That means L1 is 0. Here the limit z tends to 0, f of z means that is limit x tends to 0, y tends to 0. Why? Because z equal to x plus iy. Now similarly L2 condition. This is L1 condition. Now L2 condition. Limit y tends to 0 and x tends to 0 means, first of all, we have to substitute x tends to 0 means x is 0 and x is 0. Then we get minus of y cube into 1 minus ie by y square. That equal to, again we are substituting y tends to 0 in this equation. This y is 0 and this y is also 0. Then total is 0. That means L2 also satisfied. Here L1, L2 both are same. Now we can check it at L3 and L4 also. Also, f of 0 equal to 0. Thus, limit z tends to 0, f of z equal to 0 when x tends to 0 first and then the y tends to 0. Otherwise, and vice versa, that L1, L2 conditions are satisfied. Now, let both x and y tends to 0 simultaneously along the path y equal to mx. Then, that is L3 condition, L4 condition. Similarly, we are substituting all the conditions. Then we can check it this one also. Limit y tends to mx. This is L3 condition. Y tends to mx and x tends to 0. Now, y is nothing but mx here. I am substituting that here. Mx, m cube x cube into 1 minus I. Here x square plus y square is nothing but m square x square. Then common with y, common with the x square term, totally x cube, x square get cancelled, only x is there. That I am substituting x equal to 0 here. Here x square, x cube get cancelled, only x is there. X tends to 0, that is nothing but 0. 0 into something, overall 0. L3 also satisfied by L1, L2 and L3, all are zeros. Hence, limit z tends to f of z equal to 0. In whatever the manner z tends to 0, it all are continuous. Next, we are considering y tends to 0 and x tends to my square, mx square. Y tends to mx square and x tends to 0. That is also 0. Then the continuous function is continuous. The given function is continuous at the point origin. At the point origin is continuous. Limit existable and continuous also existable. Now, f of z equal to, now splitting the parts, x cube minus y cube into y cube by x square plus y square plus I into x cube plus y cube by x square plus y square. Separating the real part and imaginary part individually. Real part and imaginary part individually. Then the u equal to, here u equal to x cube minus y cube by x square plus y square and v equal to x cube plus y cube by x square plus y square. Also, u of 0 comma 0 is equal to 0. Then, if it is, I am substituting here 0 comma 0 in this equation. In this equation, we get 0. And here also we are substituting v value 0 comma 0 means x value 0, y value 0. Then we get 0. Then f of 0 equal to 0. Now, analytic conditions. Satisfying the analytic condition. It is continuous. Now, we are showing the differentiable of analytic condition is existable or not existable. Here, what is that condition? Dou u by dou x is equal to dou v by dou y. And dou u by dou y is equal to minus of dou v by dou x. Now, dou u by dou x equal to, in terms of 0 comma 0 function, limit x tends to 0, the derivative function. I am applying here derivative function. That is u of x comma 0 minus u of 0 comma 0 by x. The limit existable here, this is completely 0. Already we can see the before slide, this is 0 and this is u of x equal to is x. Now x by x equal to 1. Now dou u by dou x can be, value is 1. Now dou u by dou y, limit y tends to 0, y here treated as x is 0 and y is y. Now 0 comma y, then u of 0 comma 0 is y 0, then y, that is limit minus y by, here this is minus y, the function is limit minus y, then is minus y by y, that is nothing but minus 1. Now dou v by dou x. Dou v by dou x means x v of x comma 0 by x, that is 1. Next, dou v by dou y. Now 0 comma y, that is in terms of this one is the y is 1, y only. Now y by y equal to 1. Here total, the function, this is also 1. Now this is dou x and dou v by dou y both are same. Now here also dou v by dou x and dou u by dou y minus dou y is both are same. Then the function of 0, 0 is analytic. At a point 0, 0 is analytic. Therefore, the CI equations are satisfied at the origin. At the origin. Next. But f of z equal to limit z tends to 0. This is the derivative formula. Earlier we can see this one also. F of z minus f of 0 by z. Here f of 0 value is 0. F of 0 value is 0. F of z by z. F of z is nothing but here x cube minus y cube plus I into x cube plus y cube by x square plus y square. And here z is another condition is there. That's why z equal to x plus iy. That's why I am substituting here x plus iy. Now z tends to 0 among the path. Here we check it on path y equal to mx. Then the condition is f dash of 0 equal to, now this is the condition, f dash of 0 equal to z tends to 0 means x tends to 0 and y tends to 0. That is the limiting conditions. Now substituting here x cube minus y cube is nothing but m cube into x cube plus I into x cube plus x cube or m cube into x cube. Now common the terms, we get 1 minus m cube plus I into 1 plus m cube by this one. Overall we are common with x cube in numerator, in denominator common with x square here. Now here it is x. Overall the term is x cube. That means here x cube into 1 minus m cube plus x cube into I into here x cube common overall 1 plus m cube. And denominator x square is there 1 plus m square and here x is there 1 plus im. Total this is also x cube. Now the x cube cancel, remaining that part. Which is assumes different values of even though it is continuous and satisfies the CI equations, that which assumes the different values of the m various. Now f dash of 0 is not unique at 0, 0. Now f dash of 0 does not exist. Now therefore f of z is not analytic at the origin. It is not analytic at origin. That's all. It is does not existable and it is not analytic at origin. Remaining all the places it is analytic. Only origin it is not analytic. Now the conditions are completed. Now similarly, this is in polar coordinates method. If the treated as show that the polar form of Cauchy-Riemann equations are dou u by dou r equal to 1 by r dou v by dou theta. If we need dou v by dou theta, that is I into dou u by dou r. Similarly, dou v by dou r equal to minus r into dou u by dou theta. If we need dou u by dou theta means minus r into dou v by dou r. Now, and deduce that dou square u by dou x dou r square plus 1 by r into dou u by dou r plus 1 by r into 1 by r square into dou u by dou theta, dou square u by dou theta square, that equal to 0. Now the CI equation, by using CI equation, the polar coordinates are r comma theta. The point is at a coordinate point is r comma theta, whose coordinates are x comma y. Then z equal to x plus iy. Here z is also written as r into e power I theta. R into e power I theta. In earlier it is in coordinate system it is x plus iy. In polar coordinate is r into e power I theta. Now the first condition, u plus iv, that is nothing but w equal to f of z equal to f of z equal to r into e power I theta. That is equation number 1. Now where u and v are expressed in terms of r comma theta. In differentiating with respect to r comma theta in equation 1, we get the dou u by dou r plus I into dou v by dou r. The first condition. That is with respect to r. First of all, I am considering with respect to r. That's why dou u by dou r plus I into dou v by dou r. That equal to f dash of r into e power theta. R derivative here with respect to r na. That's why that is 1. And e power I theta. That is e power I theta. That is equation number 2. Next, similarly, the partial differentiating with respect to theta, that is dou u by dou theta plus I into dou v by dou theta equal to f dash of e power I theta. I here r is constant, e power I theta, the function is e power I theta into I. E power I theta into I. That is equation number 3. Now, calculating the equation 2 and 3, we get the conditions are dou u by dou r plus I into dou v by dou r. That is I r into dou u by dou theta plus I into dou theta, dou v by dou theta. These are adding these first and second equations. We get the real and imaginary parts are dou u by, we know earlier, dou u by dou r equal to 1 by r into dou v by dou theta, and dou v by, that is the given condition of the theorem statement. Dou v by dou r equal to 1 minus 1 by r into dou u by dou theta. That is equation number 5. These four differentiating with respect to r. In this fourth equation, differentiating with respect to r, we get dou square u by dou r square. Dou r square. Why? Because earlier it is there. Earlier they are asking this total condition. We need, already we have calculated this part. We need this one and this one. Okay. By using theta conditions and r conditions with respect to x and with respect to r and theta. Now, dou square u by dou r square equal to minus 1 by r square dou v by dou theta plus 1 by r into dou square v by dou theta dou r. Partially differentiating with respect to r. That means we are compulsory, we need UV method. Now, similarly, in equation 5 also, we are partially differentiating with respect to theta, that equal to dou square v by dou r dou theta, that equal to 1 by r square into dou square u by dou theta square. Then this is the 7th equation. Earlier is 6th equation and this is in 7th equation. Now using 4 and 5, 4, 5 and 7 we get this total equation. Then finally we get this one. Now the problem of polar coordinates of analytic function. If w equal to log z, find the f of z and determine where f of z is non-analytic. Analytic or not. If it is, this problem is non-analytic, they are given indirectly, then we have considering w equal to f of z equal to u plus iv. Here log of x plus iy, z is nothing but x plus z, we know z equal to x plus iy. X plus iy. I am substituting that. Now what we know, w equal to log of z, that equal to log of another, that is analytic function, but we did not need this one. We need z equal to r into e power I theta. Now considering x equal to the polar coordinates, we are considering x equal to r cos theta and y equal to r sin theta. That means x square plus y square equal to r square into cos square theta plus r square into sin square theta. Then that common with r square, that is cos square theta plus cos square theta plus sin square theta, that is nothing but 1, that equal to r square. Therefore, r equal to square root of x square plus y square. Now similarly, y by x, that is r cos theta by r sin theta. Now r get cancelled, remaining y by x equal to, sorry. Now this is r sin theta by r cos theta, that equal to tan theta. Now theta equal to tan inverse of y by x. Tan inverse of y by x. Now here substituting here, and theta equal to tan inverse of y by x. Now substituting each and every one in the conditions. Now already log of z, w equal to log of z, z equal to r into e power I theta. Then log of ab, that means log a plus log b, that is log r plus log of e power I theta. That log of e power theta equal to theta. Then I am applying that one. Log of r is nothing but square root of x square plus y square plus e power I theta, that is nothing but I theta. Theta is nothing but tan inverse of y by x. Now here square root of this one means that is log of 1 x square plus y square to the power of 1 by 2 plus I into tan inverse of y by x. Now here log of a power b, that is b log a, then that is 1 by 2 into log of x square plus y square plus I into tan inverse of y by x. That is the function. Now that is the equation of this one. Now here u equal to 1 by 2 of log of x square plus y square and v equal to tan inverse of y by x. Now analytic or not solution means dou u by dou x. Now we calculate the dou u by dou x is equal to dou v by dou y and dou u by dou y equal to minus of dou v by dou x. Now first of all dou u by dou x that equal to this one 1 by 2 as it is constant log of x. Log x derivative is 1 by x. Now 1 by x means x square plus y square. In numerator, the derivative of this one, x square derivative is 2x and y square derivative is 0. Now why? Because partial differentiating with respect to x. That's why y treated as a constant. This part is 0. Now that is 2 to get cancelled. Only x by x square plus y square is the function. Next, similarly, dou u by dou y. 1 by 2 is a constant. 1 by log of x means 1 by x. Similarly, that also. Now, x square treated as a 0 and y square derivative is 2y. 2 to get cancelled. Remaining is y by x square plus y square. Next, dou u by dou x and dou u by dou y completed. Now, dou v by, this is nothing but dou v by dou x. Dou v by dou x, that tan inverse of y by x formula is 1 by y plus x into derivative of x. Now 1 by 1 plus x square. Derivative of tan inverse x equal to 1 by 1 plus x square and derivative of this one. Now here x square means y by x. Then 1 by 1 plus y square by x square into derivative of x square means this part. That is 1 by, first of all, y by x. Derivative of y by x. Y as a constant here with respect to x. That's why y constant 1 by x derivative. That is minus 1 by x square. 1 by x derivative. Dou by derivative of 1 by x equal to, actually derivative of x power n equal to n into x power n minus 1. Now here x power minus 1. That means 1 into x power minus 1 into x power minus 1 minus 1. That is minus 1 by x square. That's why it is minus 1 by x square. Now overall y by in denominator here we are calculating the, in denominator LCM denominator part we solving the LCM method, that is 1 minus y by x square by x square plus y square by x square. Then x square get cancelled. Remaining part is minus y by x square plus y square. Now similarly here also this is dou v by dou y. That is nothing but vy. That equal to similarly 1 by x square plus y square by x square LCM at a time y by x day. Y by x derivative with respect to y. That's why y derivative is 1. Y derivative is 1 and the remaining part is 1 by x. That's why it is 1 by x. Then 1 by x means total is x square by x square plus y square into 1 by x. X square and x get cancelled. Remaining x by x square plus y square. That is the next vy. Now here, now we can check it, the dou u by dou x is equal to dou u by dou v by dou y. These both are same. Now dou u by dou y equal to dou v by dou x of minus dou v by dou x. Both are same. This one and this one both are same. See here. This one and this one both are same. Then it is analytic. Is it analytic or not? They are asking. This is analytic. Non-analytic they are given, but it is analytic. But in which condition? Hence the partial up to analytic is completed. In which condition it is satisfied? In another condition, all conditions are satisfied or not? We can check it here. Hence partial derivatives are continuous except 0, 0. Why? Because the given w equal to u plus iv. U part is now dw by dz equal to dou u by dou x plus I into dou, this is dou w by dou z equal to dou u by dou x plus I into dou v by dou x. Here dou u by dou x part is this one. plus I into dou v by dou x part is this one. Now LCM is x square plus y square, that is x minus iy. Then here x minus iy is nothing but z bar. Oh, okay. X minus iy by x square plus y square, that equal to x plus x minus iy by x plus iy into x minus iy. Now adding multiply these two, we get a plus b into a plus b into a minus b, that is a square minus b square, that is x square minus of I y whole square. X square minus I square is nothing but minus 1, that is minus into minus plus y square. Now both are same. Here that is the calculation part. Here x minus iy and x plus iy both are cancelled. Then the remaining part is 1 by x plus iy. This is the 1 by x plus iy. Now z equal to, always we know x plus iy. Now 1 by z. If z equal to 0, then this is infinite term. It is not analytic. If z not equal to 0, then it is analytic. Okay, if this function is analytic, in which condition? If z not equal to 0 condition. If it z equal to 0, it is not analytic. Hence, theorem is proved. Hence, problem is completed. Now, the next one. Harmonic functions. Let f of z equal to u plus iv be an analytic function in some region of the z plane. Then the Cauchy-Riemann equations are satisfied. Differentiating CR equations and adding we get the harmonic functions. Also call it as Laplace equation of two variables, that is dou square u by dou x square plus dou square u by dou y square equal to 0, and dou square v by dou x square plus dou square v by dou y square equal to 0. This is also written as del square u equal to 0, and here is also written as del square v equal to 0. These two conditions are called it as Laplace equation. These two conditions are satisfied, then harmonic function is satisfied the given condition, given function. If given function is satisfied in these conditions, these two conditions, it is harmonic. Otherwise, this is not a harmonic function. If the given function, they are given in u, okay, we can calculate v also. If the given function u means only del square u equal to 0 or not, we can check it. And then after v also. If sometimes they are not asking v, we can stop there only. Orthogonal systems. U of the condition, consider two families, that is u of x comma y equal to c1 and v of x comma y equal to c2. That is equation number 1 and 2. Differentiating with respect to 1, differentiating 1, we get dou u by dou x plus uv, applying uv, dou u by dou y into dou y by dou x. Now cancellation these two, we get the earlier one, that equal to 0. Now similarly here applying second equation also we are applying that from the orthogonal methodology system. We have analytic function. Analytic function f of z equal to u plus iv defines two families of the two individual curves. Now u of x comma y equal to c1 and v of x comma y equal to c2, which form an orthogonal systems. Now the problem. If show that u of x comma y equal to x cube minus 3xy square is harmonic, and find its harmonic conjugate. Find also the corresponding analytic function of f of z in terms of z. We can see this is in next session. Okay. Now here it is harmonic means the Laplace equation can be satisfied. These two are the Laplace equations. We can satisfy these two conditions, then it is harmonic. If it is not satisfied, then this is not a harmonic condition. First of all, we can solve the dou u by dou x. Then after dou square u by dou x square. Next dou u by dou y. Then after dou square u by dou y square. These four conditions, and these are the adding these two. That means dou square u by dou x square. Next this one also plus dou square u by dou y square. Dou square u by dou y square is equal to 0. One condition, and another similarly dou v by dou x. Next dou square v by dou x square, and dou v by dou y and dou square v by dou y square all are satisfied. That means these two equations, that is dou square v by dou x square plus dou square v by dou y square is equal to 0, then the function, that analytic function is harmonic. Is harmonic. Every analytic function is harmonic, but converse need not be 2. Converse need not be 2. That means dou u by dou x is equal to, that is analytic function, that is dou v by dou y, and dou u by dou x, dou u by dou y is equal to minus of dou v by dou x. This is analytic. These two conditions are analytic, then it is harmonic. The function is harmonic, the given functions are harmonic, but converse need not be 2. That is not necessary for the conditions are analytic. The converse need not be 2. Then that is also harmonic, one of the important condition. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.